Okay, so this B part of the question says, is it possible to implement the system using a finite number of adders, multipliers, units, delay? If yes, how? So the solution is that yes, it is possible. So it is possible. So and how do we go about that? First of all, we need to write down the h of z. And that h of z, of course, is y of z all over x of z. So which is this expression that we obtained earlier. And that is 1 minus 1 all over 4 root 2 0 is to the power minus 1 all over 1 minus 1 all over 2 root 2 0 is to the power minus 1 plus 1 all over 16 0 is to the power minus 2, right? So what we just need to do at this point is to, cross multiply so that our y of z will multiply 1 minus 1 all over 2 root 2 0 is to the power minus 1 plus 1 over 16 0 is to the power minus 2, and our x of z will multiply 1 minus 1 all over 4 root 2 0 is to the power minus 1. All right, so now what we'll do at this point is to expand the brackets. Y of z minus 1 all over 2 root 2 0 is to the power minus 1, y of z down plus 1 all over 16 0 is to the power minus 2, y of z. And this is going to be x of z minus 1 all over 4 root 2 0 is to the power minus 1, x of z. So make y of z the subject of the formula. So this is going to be x of z minus 1 all over 4 root 2 0 is to the power minus 1, x of z. Now you bring the others to this side of the equation. That will be plus 1 all over 2 root 2 0 is to the power minus 1, y of z minus 1 all over 16 0 is to the power minus 2, y of z. So now this expression can now be converted back to the time domain. It is in the z domain now. So we want to return it back to the discrete time domain. And we do that simply by just reversing the situation. It's going to be y of n, this is going to be x of n, and this is going to be 1 all over 4 root 2. 1 all over 4 root 2 x of n minus 1 plus 1 all over 2 root 2 y of n minus 1. And this is going to be minus 1 all over 16 y of n minus 2, right? So at this point we can now draw the filter. So the filter, that it has one delay, which is this one. So after that delay, this y has two delays. So x of n is coming from here. So we can represent this one. So this is the output y of n. So this has a delay. It has two delays. So because it has two delays, we have to represent with these two delays. So multiplier, then it goes here. And so this is going to be y of n minus 1, and this is y of n minus 2. Y of n minus 2, all right? So, and this is where the multipliers are. So you see that this is x of n. It also goes here. Then the other part is this guy here. It is as 1. This one has minus 1 all over 4 root 2. Right? After the delay, this is x of n minus 1. So it now multiplies this before it goes into this addition. Then while this one also at this point, it turns to y of n minus 1, then is multiplied by 1 all over 2 root 2 at this point, while this one is multiplied by minus 1 over 16, right? So when it is now added, so everything now adds up to give us this y of n. So I believe this is clear.